Hi, everybody. All right, so somebody wanted me to run the day and night cycle of the flat Earth, and then someone wanted me to do why the sun rises and sets on a flat Earth and how that's even possible. Well, they have to do with two different things. First, you have to remember that the way the sun and moon exist on the flat Earth is basically coming into the grid area around the Tropic of Cancer, Tropic of Capricorn, and although that might not be exactly where they line up in the atmosphere, that is periodically where we see their movements and their angular rotation thereof. And basically, that spin gives us the day and night because the sun does kind of move around the earth like that. And we have to also contribute that it's an anode diode, I think dipole, anode dipole. Well, I forget my exact words on that, but it's basically one's a positive charge, one's a negative charge, and the counter magnetisms, which we cover a lot on magnetisms, basically allow the two to spin along the Tropic of Cancer, Tropic of Capricorn, and depending on the light's exact position or lack thereof, is thereabouts related to the subject of what month it is, what day it is of the month, and everything like that. Now, the sun rising and sunset is actually a little bit more easier to understand. It has to do with perspective and the idea that as this is moving in its rotation, that basically your perspective is seeing it at 1,000 meters, at 2,000 meters, at 3,000 meters, etc., from where it was, right? And I'll show you this in a video in a little bit. But basically, that draws it out to where it looks like it's closing in the horizon when it's actually perspective theory, which means your eyeball only can see so much of that until it basically becomes a glimmer. Well, same thing basically happens with the sun rising and setting, is that perspective theory or perspective gradually gets smaller until it basically fades away, quote unquote, even though we know it never really does. And basically the idea on that is the same thing for the sunrise as it is for the sunset. So while I don't have this completely worked out, you can definitely tell that there is a lot of information involving this. I covered the day and night cycle a little bit on one of my earlier videos. The one where I did all the weather patterns and stuff. So you can review that for a little bit more on this. But basically, I covered that the sun moves on the Tropic of Cancer, Tropic of Capricorn. I would say belt, but really what it is it's a perspective of it moving in that spot. I don't actually believe that it's, moving at that exact spot, but it appears to, and rationally, that's where we view it from. So rationally, that's where I look at it from. And depending on the month and day of the month of the year, you get the various timelines, the various times of day, and various things in different parts of the world. Now, I will cover time zones in another one altogether because that gets into a little nitty-gritty work. But right now, I just wanted to bring this to you and get this out of the way so that you can actually see this for yourself. I have a video here, which is actually great, which I'll share in the end of this, but let me just show you real quick. So this basically covers how at 1,000, 2,000, 3,000, I think his unit he's using is miles. but could be meters. Let me just play the video a little bit. It'll tell you the sun sets just fine on a flat earth. The math was wrong that his buddy was telling him about. But it's actually a good idea to watch this all the way through so you get an idea what's going on. I'm not going to show you a lot of
everybody, P-Brain here. I got inspired to do a video. I've been discussing on a couple of my videos about this notion that the sun would never make it to the horizon, and a couple of people show me diagrams, and I hadn't come up with a really good illustration to completely debunk this idea until now. So that's why I got inspired to do this video.
His units are miles.
Yeah, first of all, let me just say I don't know how high the sun is, so I'll just go with the 3,000 miles that many flat earthers use, and that's what I'm going to use for this video.
At 6,000
This guy sent me this picture, and he's got all the maths included, and it looks good, you know. At first, I had a little tough time with it because there's a couple things true about it, right? It's showing the sun traversing over the ground, over the flat earth, and it's parallel to the ground. So it had that going for it. And it's showing that when the sun is further away from you, it angles down, just like perspective. Same as this guy, Daz, the cameraman or something is his name. He has a video out and he shows this picture. And it's the same thing. It still shows a parallel sun to the ground. And instead of moving the sun, he's moving the observer. But it's the same diagram. If you flip it upside down, it looks like identical. Anyway, so it's the same notion. So I was a little bit perplexed. I was like, wait a second, you know, makes you start to doubt. But I mean, I know it's wrong, but I was like, wait a minute, it's got perspective. It's so I thought. And then
it also
hit me. What's wrong with this picture?
Well, he's going to
What's wrong with this picture is that they are attempting to calculate visual angles to the sun from a non-visual, non-perspective drawing.
Right.
So the drawing is not taking the visual perspective of the observer into account. And that's what's wrong with this diagram. You see, you cannot calculate visual angles to convergent positions, which is where the sun is from the observer, by using non-convergent parallel lines, which is what the diagram is. You have parallel lines and they're drawing visual angles to it. It's true that this drawing is an accurate representation of actual relationships and positions of the observer to the sun, but it's a non-perspective side view representation. So this diagram is not accurate at all as it relates to the perspective of the observer. So if we add perspective lines, we get a completely different picture.
There you go. And there's your perspective.
All right, take a look at this wall of lines. Now, this wall is not an illustration. It's not a cartoon. It's a photo. It's reality. Okay? The here has a it's nothing but some geometry. I mean, they're showing us some angles, but it has nothing to do with perspective and how we would see the sun. So it's bunk. So in this next slide here, I'm going to superimpose these lines, the perspective lines, over on top of this. Okay, here we go. All right, and as you can see, the way they're representing the sun as staying parallel to the ground is not correct. The sun would follow these perspective lines, and what they really are is spatial planes, right?
Right.
They're invisible spatial planes that are around your z-axis. Now your z-axis goes from your eyes, a straight line out from your eye in any direction. Okay, that's your z-axis. So anything parallel to that will start to converge toward that focal point or the horizon, right? In line with that z-axis. Everything does. Any lines going away from you are going to all converge. Yet this diagram that they show us, saying that these are the visual angles to the sun, have no convergence. The lines are parallel.
Right, and that's
what I meant. These parallel lines,
convergence.
And look how they converge. They completely go against this geometric drawing or these angles and these formulas.
Well, I think it's actually backwards is what it is.
So anytime someone brings this up, bring them to this video, show them this picture, and this is the reality. The photograph is a reality. That's how we see everything.
Right.
So this representing the sun is going away from you parallel to the ground, and then calculating your angles to the sun based on that is wrong, and it doesn't work. Okay, and quickly notice with this line of converging parallel lines or planes. Notice how the higher up they get, or the further away they get from the yellow line, which is your z-axis, notice how they orient themselves more and more vertically and less horizontally. Also notice how all the lines converge at the same point, the vanishing point. It doesn't matter how high they are, they all go to the same place, which, interestingly enough, means that no matter how high that object is going away from you, it visually goes to the same place.
Yep.
Okay, here's the wall of lines again. Notice that these are true perspective lines. These are parallel lines, but from the observer, which is this little guy down here, this is what these parallel planes or parallel lines would look like. They just happen to be represented by these
And that's basically what I'm going to show. So as you can see, folks, both of these are actually right there in the open, and this is what you need to know. Now, I'm going to show you 3 different models on this. I'm going to show you the day and night on the flat Earth, the globe Earth, and I have a another map. I think it's a meteorological map, so that you can see just how this day and night cycle works. And if you follow what they just said on the rise and or the sunrise and sunset, you can see how it's all connected together. Hi everybody. Alright, so I have the actual video of a day and night. It gets a little bit into seasons. And if you remember my video on the weather and other things, I basically broke it down and told you there's a whole lot of different things in terms of the intensity over the year, where the shadow is, and how basically everyone theorizes that the sun looks like it's moving over different areas brighter than others, when it may not even be moving at all, but some people view it as actual movement of the sun and repositioning of the sun, which I don't view it as that. I view it as a like an ocular disruption and many different things along the lines of that. So what I'm going to do is I'm going to show you something I found. This guy really does sum this up quite well. And without further ado, I'm only going to show you about 3 minutes of this so that I can show you what this is really about. Interpretation.
So you got the same type of situation as the globe, where it can be daytime in China and nighttime in the U.S. of America. See, it's because the sun goes around the circle plane like a dish plate, you know. So
Tropic of Cancer, Tropic of Capricorn,
and goes in a circular motion, and you still get the same type of time zones and everything. And as far as seasons is concerned,
I don't know why he has 2 bulbs.
The sun doesn't just go in the same path. It goes from, it takes different paths. It works its way to the North Pole circle, and it goes around that, and then it works its way to the...
Let me read this for you a little bit. Understanding Seasons on the Flat Earth Model. A rough first draft by Rob Skiba. Summer, north of the equator, 854, looks like 10 south of the equator. Disclaimer, or winter. Disclaimer, this animation is not meant to illustrate the exact movements of the sun and moon. It is merely demonstration purposes only.
For the winter, it works its way to the Antarctic region and circles around that area. So you get your seasons based on that, because when the sun is in the Antarctic region going around that circle, you know, kind of like a record player as it spins on the needle works its way to the outer part and from the inner part. So that's your seasons right there. And with the Antarctica trip around the circle, the sun is farthest away from America, so we get the colder temperatures.
All right, and that basically gives you a shortened welcome into the situation. So this is basically what they're trying to tell you, and that on a flat Earth, this is going to actually work. It is going to work well, and the math and the science is there in the background if you want to explore it for one date or another. So I just wanted to bring you this today to tell you that this does actually work. This is not hokey. This is just stuff that was known thousands of years ago. And when they say that, that it's on the circle, what they're actually referring to is about the perspective of where the sun is and representation of the light and movement of the sun that we can see. It doesn't necessarily mean that's exactly where the sun is. I think the number was 3 million miles above the Earth, or whatever number he used in the video. So when I'm referring to that, I'm referring to the second part of this that I believe may come after or before this one, depending on how I show it. But there's going to be a reference to that kind of number, so just look for it. And I look at the sun and I think there's no way it's like 90 million miles, because there's no reason to have that kind of an open area and have nothing but void. I've gone over this a dozen times. And so I think it's a lot closer. I think all of the planets and all the solar systems and all the galaxies and stuff are a lot closer and a lot smaller than the general perspective allows us to see it as. I apologize for the plane going over if you guys can hear that. I'm just going to say thank you. And as you can see here, folks, you can actually see the movement of the actual sun and the moon, and everything is good. This comes from a side view. This comes from a top view. This is another top view with a little bit more color. And as you can see, it works out quite well. Here's the globe view, or globe model. Not that impressive, a little bit too hokey, but okay, fine. And here's the regular meteorological map and the way it looks on the maps that you would be used to seeing. So last but not least, you can see that the day and night cycle can work on the flat Earth, and the sunrise and sunset feature can work on the flat Earth as well. The day and night has a lot more to do with its cycle around the Tropic of Cancer, Tropic of Capricorn, and where the light is focused thereof between the seasons and the months and the days of the months. The sunrise and sunset effect has to do with perspective and the angular, visceral, or visual atonement to the reality of what angle the sun is at the moment of its perspective. And at that point, it looks like it's further away at different angles as you move further or closer to its point in the sky. from wherever your point is on the perspective. So thank you guys. A bit more easier to understand. It has to do with perspective and the idea that as this is moving in its rotation, that basically your perspective is seeing it at 1,000 meters, at 2,000 meters, at 3,000 meters, etc., from where it was, right? And I'll show you this in a video in a little bit. But basically, that draws it out to where it looks like it's closing in the horizon when it's actually perspective theory, which means your eyeball only can that, but it's basically one's a positive charge, one's a negative charge, and the counter magnetisms, which we cover a lot on magnetisms, basically allow the two to spin along the Tropic of Cancer, Tropic of Capricorn, and depending on the light's exact position or lack thereof, is thereabouts related to the subject of what month it is, what day it is of the month, and everything like that. Now, the sun rising and sunset is actually a little bit in the atmosphere. That is periodically where we see their movements and their angular rotation thereof. And basically, that spin gives us the day and night because the sun does kind of move around the earth like that. And we have to also contribute that it's an anode diode, dipole, anode dipole. Well, I forget my exact words. I can see so much of that until it basically becomes a glimmer. Well, same thing basically happens with the sun rising and setting, is that perspective theory or perspective gradually gets smaller until it basically fades away, quote unquote, even though we know it never really does. And basically the idea on that is the same thing for the sunrise as it is for the sunset. So while I don't have this completely worked out, you can definitely tell that there is a lot of... Hi, everybody. All right, so somebody wanted me to run the day and night cycle of the flat earth, and then someone wanted me to do why the sun rises and sets on a flat earth and how that's even possible. Well, they have to do with two different things. First, you have to remember that the way the sun and moon exist on the flat earth is basically coming into the grid area around the Tropic of Cancer, Tropic of Capricorn, and although that might not be exactly where they line up,